Lesson 11 is solving linear systems by substitution, and we've learned a little bit about linear systems before. We've solved them by graphing, so just as a quick review, when you solve linear systems by graphing, say you have an x and a y-axis, and then a linear system is two or more equations put together. So on a graph, they end up being two or more lines on that same graph. So let's say I have one and then another right here. And then their solution is the point where they intersect. So let's say, again, just a sketch, let's say this is the point 3, 1. That point is the solution to the system. It's a point or a set of x and y values that satisfy both of the equations that would go with these lines. So in lesson 11 and in lesson 12 too, we're going to learn about ways to solve systems more algebraically. So 11 is substitution. And 11.1, it's solved by substitution when both of the equations are in slope-intercept form, which remember slope-intercept form, that's y equals mx plus b. So it's just kind of saying like what the structure of the equations are that were given. So the first example where it says intro, we'll find the solution to the system y equals 8x plus 12 and y equals 6x plus 18. So think about what the word substitution or like substitute means. It means to like put something into another's place. So that's exactly what we're going to do here. We're going to put one equation into the other. So you always want to make sure that, before you use substitution, at least one of the equations has a variable isolated, and that means it's by itself. So like here we have y that's isolated. Here we do too also. So we have both equations where the variable is isolated. It's not mandatory that that's the case, but we need at least one of them isolated. Okay, so what we can do is if I'm saying y is equal to 8x plus 12, I can take that 8x plus 12 and I can put it down into this equation where y is. Because like both y's, like they need to have the same value because we're looking at where the systems or where the equations intersect. So as long as we're saying that they're both equal to y, I can take this 8x plus 12 that I'm saying is equal to y and put it into the second equation where y is. Likewise, you could also go the reverse way. So you could take the 6x plus 12 and put it into the first equation where y is, and you'll end up getting the same exact answer. I don't really think there's one way it's better than the other. It's just totally up to you. So I'm going to take the 8x plus 12, put it into the second equation where the y is. So instead of starting with y, it's going to be 8x plus 12 and then equals 6x plus 18. So another way of thinking of it is like, let's say if we like physically want to just like substitute it in. So the second equation was originally that like y equals 6x plus 18, like these are the same. I said I was going to take the 8x plus 12, substitute it in for y, so that's what I'll do. I'll take the y, move it out, I'll move the 8x plus 12 in. So it replaces it, and the y goes away completely. And the reason I want the y to go away completely is because now, like, I only have one type of variable, and this is like new equation I only have x's. And so if you only have one variable, you can solve for that one variable with just one equation. So if we want to solve for x, the first thing that we want to do is we want to try to get our x's together on the same side of the equation. So like right now I have a 6x and an 8x, but they're on different sides of the equal sign. So I got to get them together. I would suggest taking, well, in this case, they're both positive, so I would maybe take the smaller number and try to move that to the other side. And I'm not just like physically like moving it over. I have to use inverse operations to cancel it out on the right side. So what I'm going to do is subtract 6x, because if I do 6x minus 6x, that'll wipe it out on that side. And then I also have to subtract it over here, because whatever I do to like the left side of the, or the right side of the equal sign, I also have to do to the left, so I have to do it to both sides. And then from here, I can subtract 8x minus 6x. I just need to subtract the coefficients. Those are the numbers in front. That would become a 2x. And then I bring down the plus 12. And then 6x minus 6x is something minus itself, so that's just 0. It's canceled out, which is exactly what we were trying to do. And then I have to bring down the 18. And then now it looks like more of our typical like two-step equation that we solved a bunch of. So our goal is to solve for x. So we want to get x by itself. So next I would subtract over the 12. I would bring down my 2x. And sorry, I said subtract over, but I should have been more specific. This plus 12, I need to undo by subtracting 12. And then if I subtract 12 from the left side of the equal sign, I need to also subtract it from the right side. So if I do 12 minus 12, that is 0, so that goes away. And then I need to remember to bring down my equal sign. And then 18 minus 12 is 6. And then still same goal, try to get x by itself. Now the 2 is being multiplied by the x, so I would have to divide both sides by 2 to undo the 2 that's being multiplied. Once I do that, I'm left with just a 1x, but we don't have to write the 1 in front, and then 6 divided by 2 is 3. So we finished solving that equation, but remember that when you have a solution to a system, like the little example that we did up here, the solution is a point, and points have x's and they have y's. So we found the x and we still have to find the y. There's two parts to every answer for these. So I have my x equals 3. As soon as I know that x equals 3, I can go ahead and I can put it into either equation and solve for y. Doesn't matter which one, you can pick whichever one you want. I'm going to pick the first one. So I'm just going to rewrite it up here. Y equals 8x plus 12. But I just figured out that for this system, x is equal to 3, so I'm going to put that 3 right there in for x, and then that will allow me to solve for y. So it'd be y equals 8 times 3 plus 12, and then y equals 8 times 3 is 24 plus 12. I would have to multiply this before adding the 12 in. So 8 times 3, 24 plus 12. And then now I could finally add the 24 and the 12. So I would end up with y equals 36. So we have our answer for x. That was 3. We have our answer for 36. Or for y, that was 36. And then now we just want to write our answer solution together as a point. So, you know, like for points, their range is x, y. So we would write our final answer as 3, 36. X was 3, 36 was y. Okay, so there is a way for us to check our work with systems, and it's really helpful. It's worth the time to check for sure. So what we need to do is we need to pick the other equation, the one we haven't used, or the one that we didn't use to find y. So like to find y, I used the first equation. I'm going to take the second equation, and I'm going to put my x and y values back in there and see if it makes the equation true. So for the check, I'm going to use the second equation this time. So the y equals 6x plus 18. And I'm going to take the 3 and I'm going to put that in for x, because that was my x value. And I'm going to take the 36, I'm going to put that in for y, because that was my y value. So this would be 36 equals 6 times 3, because that was x, plus 18. And then I keep my 36 over here, and I multiply. 6 times 3 is 18. And then I bring down the plus 18. And then I have 36. And then equals 18 plus 18, which is also 36. So I made the equation true. I got the same answer, or the same number, on both sides of the equal sign. So my check worked. I won't do a check on every problem, just because I would like to keep the video not super long. But just know, like, you know, especially when you're doing check boards, especially when you're taking an exam, like, you can check your answers, and you should, just to be safe. So our solution for this problem was 336. Okay, so now on to example 1, and you'll see why once we get to example 1, I wanted to put this kind of intro problem here, because they give you a little bit of funky answers for example 1, so I did not want that to be the first problem that you saw. So same setup, y equals 7x minus 4 and y equals negative 2x plus 4 is our system. So I'm going to treat it the same way. If this 7x minus 4 is equal to y, then I can take that and I can put it in the second equation where y is. So when I do that, the whole 7x minus 4 is going to swap in right here. So then that would become 7x minus 4, support that I substituted in for y, and then is equal to, just like the other part of this equation stays the same, so minus 2x plus 4. And then now I have my equation with just x's, so I can go ahead and solve for x. So in order to solve for x, first I want to get my x's on the same side of the equation. So I have this 7x and I have this minus 2x or slash negative 2x. So I think I want to move the negative 2x. So to undo a negative 2x, I would need to add 2x to both sides. Since it's a negative, so I'd have to add a positive 2. And then I would add 2x over here. So then 7x plus 2x is 9x. And then I bring down the minus 4, and then negative 2x plus 2x, that's 0, so that cancels out, which is what we were trying to do. And then I have to bring down the 4 right here. And then now my goal is to move everything away from the x now that I have those terms together. So I would want to cancel out this minus 4 right here. In order to do that, I would add 4. I would add 4 right here. And then I would bring down my 9x. And then negative 4 plus 4 is 0, so that goes away. That's what we wanted to do, just cancel it out. And then 4 plus 4 is 8. And then still same goal, trying to get x by itself. So if I have a 9 times x and I want to get rid of the 9, I would have to divide both sides by 9. And then 9 divided by 9 is 1, so that goes away, and I'm left with just a 1x, but I don't need to write the 1 in front of it. And then 8 divided by 9 is a decimal, and it's a decimal that doesn't like terminate, it goes on forever. So we really want to leave this as a fraction. And that's what makes this problem a little bit more challenging than the first one. So we'll leave our answer as 8/9, x equals 8/9. And I still have to find y. So I'm going to take that 8/9 and I'm going to put it into one of the original equations. It doesn't matter which one, you just have to pick one. So I'm going to use the first one. Like I said, you could use either one. So I'm going to write it right here. So y equals 7x minus 4. And then I have to take that 8/9 that I just got for x and put that in there. So this is going to be y equals 7 times 8 over 9 minus 4. So the 8/9 just replace the x. And then now we'll work on, we just have to, well, but we have to simplify that half of the equation to get our answer for y. So if it's helpful, you can write 7 over 1 if it's like, and then when we multiply a fraction, we just multiply straight across. So y equals, and then I'll multiply straight across. 7 times 8 is 56 over 1 times 9 is 9. And then I know I'm going to bring down my minus 4. However, I'm going to have to subtract it from a fraction, so I kind of just want to get my common denominator. So I have to get the same denominator as this 56/9, so my denominator is going to be 9. So I have to take that 4 and multiply it by 9 over 9. And if you want the same thing, you could do 4 over 1 times 9 over 9. And then we'll bring down just like the minus sign. And then 4 times 9 is 36 over 1 times 9, so 9. And then I have my common denominators. I'm ready to just subtract the numerators. So I would do 56 minus 36. So I have y equals 56 minus 36 is 20 over 9. Okay, so we ended up with x equals 8/9, y equals 20/9. That's why I didn't want to start with this problem, because I don't want to scare anybody more than maybe it already is. And then we just need to write our final answer as a point, like, in parentheses and then xy. So 8 ninths was my x, and then 20 ninths was my y. Then example 2. So find the solution for the system. Same instructions each time we're finding the solution. For example 2, same exact setup, same exact starting point, just probably a different answer, I would assume. So y equals negative 3x minus 2, and y equals negative 3x plus 5. So if negative 3x minus 2 is equal to y, then I can take it and I can put it into the other equation where y is also, because it's equal to y. So I'll put it in there. So this whole thing replaces the y. So then that would become negative 3x minus 2 equals negative 3x plus 5. And then now I have an equation that just has that one variable. It has x, so I can go ahead and solve for it. So my goal first is to combine the x's together on one side of the equation. Doesn't really matter which one we start with, you just have to pick one. So let's say I want to get rid of the negative 3x that is on the right side. So to cancel out the negative 3x, I'm going to have to add 3x, because negative 3 plus 3 would be 0. And then I also have to add it right here. So it's kind of funky because, right here, negative 3 and negative 3 plus 3 is 0. So technically, that would be 0. I could just cross it off if I wanted to, or I could write 0 there. I'll bring down the negative 2, and then right here, negative 3x plus 3x is also 0, because it's like you're adding the same number, but they're opposite signs, so they just wipe each other out. So that's gone too. And then I can bring down my 5. My variables are gone, but I have something that doesn't make sense. So I have negative 2 equals 5, which obviously that's not true. So it means that we stop there. And that's a special type of problem. It's when there's no solution. And that means on the graph, there would be no intersection points. So I don't know if you remember from the previous lesson when there's no intersection points on a graph. I'm just going to do a quick sketch. Let's say one is like this, and then one line's like this. The reason that there's no intersection points is because the lines are parallel. So there's nothing that makes them cross each other if they have the same slope or the same angle. And if we look back at the original problem that we had, both of the m's were negative 3. So they had the same slope, so they were parallel. So it makes sense that we ended up with no solution. Okay, so moving down to 11.2, this is one where we just have one equation with the variable isolated as opposed to both, like we did up here. Hopefully that was a good introduction to substitution. And then just remember, you can always rewatch any of the examples you need to. So 11.2, example 1, find the solution to the system y equals 5x minus 8 and negative 11x plus 2y equals 4. So on this, or let me backtrack. On the previous problems, we got to choose which equation or which part of the equation we substituted into the other. So how we said, I could have done 6x plus 18 up here, or I could have done 8x plus 12 up here. With 11.2, we don't really have the choice. We can, but that would make the problem a lot more difficult. We're only given one equation where the variable is isolated, and on this one, it's the first one. So I only have that y equals 5x minus 8, where y is by itself. Over here, it's 2y, and then the negative 11x is on that side also. So having the variable isolated means it's completely on its own side of the equal sign, like this y is. So if I'm saying that 5x minus 8 is equal to y, I can just take it and I can put it into the second equation where y is, because it's equal to y. So why not? They have the same amount, the same value. Okay, so that's what we'll do. So I'm using the second equation kind of as my shell or my base. So most of it is going to stay the same. So the negative 11x and then plus 2y, but instead of y, this whole thing is going to go in there. And since 5x minus 8 is multiple terms, I'm going to have to use parentheses to group it together. So parentheses after the 2, 5x minus 8, and then close parentheses, and then the rest of the equation stays the same. So after the y in the second equation, there was the equals 4, so I'll have the equal 4 here as well. So I just want to compare, like, the similarities and like the differences now between the original equations and our new one. So my second equation started off with negative 11x and then plus 2. I have negative 11x plus 2 here. It ended with equals 4. This ends with equals 4. The only thing that is changing is I took the 5x minus 8 that this equation said was equal to y, and I put it into the second equation where y was right here. So it really is like, whatever equation you're substituting into, you think of as kind of like a base or like a shell, and the other equation goes into it, just kind of in expression form. Okay, so now our goal is to solve for x. So we got some cleaning up to do on this equation before we can even do that. We need to make sure that before we start to isolate x, we simplify the equation as much as possible. So like over here, this is 2 times the parentheses, so I'm going to get rid of those parentheses. I'm going to go ahead and distribute. So I would bring down the negative 11x, and then plus, and if I distribute the 2, it would be 2 times 5x, which would be 10x. Just do 2 times 5. And then the x kind of tags along. And then 2 times negative 8. So a positive times a negative is a negative, so this is going to turn into a minus. And 2 times 8 is 16. So negative 16 minus 16, same thing. And then bring down the equal sign and the 4. And then you always want to check for if there's any like terms that you can combine. I do have some like terms right here in the negative 11x and the 10x. So they're like terms because they both have x to the first power. So to combine them, I would add negative 11 plus 10, which is negative 1. And then the x just stays the same. Minus 16 equals, bring down the 4. And then if you want, you do not need to write the 1, but you would have to write the negative sign. So it's up to you on if you keep it or not. I'm just going to actually keep it there because it doesn't hurt right now. Okay, so now we want to get the x by itself. So goal is to get x by itself. Now that everything, there's no more simplifying I can do over here. So now I can start moving things away from the x. So in order to do that, I want to cancel out the 16 that is being subtracted from x. So to cancel that out, I would have to do the opposite of subtracting 16, and I would add 16, and then I need to also add it to the other side of the equal sign. So I would bring down my negative 1x, and then if I add negative 16 plus 16, that is 0, so that goes away. And then I would bring down my equal sign, and 4 plus 16 is 20. So I'm running out of room. I'm going to rewrite this up here. So I have negative 1x equals 20. And here's where, I think it's kind of nice to have the negative in front, because when you see, okay, negative 1 is in front of the x, and I need to get rid of that negative 1, that negative 1 is being multiplied by it. So to undo multiplying by a negative 1, I would divide by a negative 1, because multiplication and division undo each other. And then I would divide by negative 1 here as well. As an alternative, I think maybe it's a little bit more confusing sometimes if I just have negative x equals 20 to recognize, hey, I gotta turn that negative x into a positive x. You would still do the same thing. You would have to either you would divide by negative 1, or technically you could multiply by negative 1 also. Okay, so that's why I kind of like leaving the negative 1 in front. And then negative 1 divided by negative 1 is a positive 1, but I don't need to write the positive 1 in front of the x. And then 20 divided by negative 1. Any number divided by negative 1 is the same number, but since we're dividing a positive 20 by a negative 1, it turns into a negative 20. So we have our x, and then you just have to remember that when you're solving a system, you have to find the y also. So here's where, paying attention to what equation you're picking is worth your time. So I'm going to take this x equals negative 20, I'm going to put it into one of the 2 original equations. Pick the easier one. Don't pick the second one, pick the first one. It's just going to make your life a lot easier. So you want to pick the most simple equation that you can see. It's even better if the y is already by itself. That's going to cut down on the steps. So I'm going to take that negative 20 and I'm going to put it into the first equation where x is. I'm just going to rewrite it over here first. So y equals 5x and then minus 8. So that negative 20 is going in for that x right there. So then this becomes y equals 5 times negative 20 instead of x. And then minus 8. And then I follow order of operations now to simplify. I just want to simplify like this whole side of the equation. So it'd be like PEMDAS or GEMS, depending on how you like remember order of operations. So multiplication before subtraction. So I'll multiply those. So it'd be y equals 5 times negative 20 is negative 100. And then minus 8. And then now I can go ahead and subtract these two. Negative 100 minus 8 is negative 108. So y equals negative 108. So we have our x, we have our y, and then now we just need to write our final answer as a point. So negative 20, negative 108. And then just a reminder, like you can check your answers. I'm just not on the video just to save you guys a little bit of time in watching it. But if you did want to check it, you would take your x equals negative 20, put that in here. You would take your y equals negative 108, put that in there, and then simplify, and you should end up with 4 equals 4. Okay, so 11.3, these are the more challenging problems from this section. You know, they kind of build on each other. So 11.3 is when you have no variables isolated, which means that, you know, there's no variables completely by themselves in the original problem. That doesn't mean we can't use substitution. That means that we have to do more work before we can use substitution. Okay, so there are more than there's more than one route that you can take on each of these problems. So just know that there's like solving systems is one of those like types of math problems where you can go about it a different way, like a completely different way than I do, and still end up with the right answer, and that's totally okay. Okay, so when you're deciding like which variable to isolate, if we look at example 1, it's y minus 3 equals 5x minus 1, or 5 times x minus 1. And the second equation is 4x plus 4y equals 16. So we want to get a variable by itself. So one option or thing to look for is a lot of the time, if there's any variables like already kind of with a coefficient of 1 where there's no number in front, that might be something to focus on. So that y is something for us to focus on. Another thing that you can look for is, so if we look at the second equation, these coefficients are 4, but everything in the equation is divisible by 4. So if I really wanted to, I could just go ahead and divide the entire equation by 4 as long as I'm dividing every single term, and that would be okay. So I think that's what I'm going to do because it's just going to give me an easier equation to work with anyway, so I might as well. So if I divide everything by 4, I just have to divide all 3 pieces. So I would do 4x divided by 4, which is x, 4y divided by 4, which is y, and then equals 16 divided by 4, which is 4. Okay, so doing that, as long as I divide every single piece, is not going to alter my final answer. It's okay. And then now I kind of want to simplify the first equation before I really do anything else with it. So let's say I would like to get rid of the parentheses. I think I'm just going to go ahead and do that work down here. So y minus 3 equals 5 times x minus 1. So I just want this equation to be a little bit simpler. It looks complex right now. So the first thing I'm going to do is distribute the 5. So I'll bring down my y minus 3 equals 5 times x, so that's 5x, and then 5 times a negative 1, so that's negative 5. And then now if I'm looking, like this equation is pretty close to having y isolated. I just need to get rid of that minus 3, and I know how to do that. It's like the same process as if we were solving. So we're just solving for y in this case. So I want to get rid of that minus 3. So to undo minus 3, I have to add 3. And then I'm not going to add it to the 5x because it's not like terms. They don't have the same variable. I'm going to add it to the minus 5 because they both have no variable. So I would do plus 3 right here. I would bring down my y. Negative 3 plus 3 is 0. So that goes away. And then I bring down my equal sign. And then bring down my 5x. And then negative 5 plus 3. So if I start at negative 5, picture on a number line, and I go up 3, it brings me up to negative 2. So y equals 5x minus 2y. So now I have a variable isolated. So if it's helpful, you can rewrite. I'm just going to kind of rewrite this system so far. This new equation down here it started here. So it's just replacing it. So this is y equals 5x minus 2. And then from there, this is just my new system. So I really don't even have to worry about those like more complicated problems that we started with. I can just use my new ones and focus on those. So in the first equation, I said that, 5x minus 2 is equal to y. So I can take that 5x minus 2 and I can put it in the second equation where y is. So when I do that second equation, this is my shell. It's x, and then plus, instead of y, it's going to be plus 5x minus 2. That whole thing replaced y. And then equals 4. And then now I want to simplify. So I can look for like terms. I have a 5x and a 2x, I have a 5x and an x that both have x to the first power, so I can combine those. Remember, if there's no coefficient, then it's a 1. So I would just combine them by adding 1 plus 5 together to get 6x. And then minus 2 equals 4. Now my goal is to get x by itself, so I have to use inverse operations to do that. So I want to undo the 2 that is being subtracted. So to undo that, I would add 2 right here. I need to add 2 to the other side also. I would bring down my 6x, and then negative 2 plus 2 is 0, so that goes away, equals, now I just need to add my 4 plus 2, which is 6. Still trying to get x by itself. Now I have a 6 that is being multiplied by the x. So to undo multiplying by 6, I would divide both sides by 6. So 6 divided by 6 is 1. So this goes away and it would become a 1x. When the other side of the equation is like, in this case, 6 divided by 6, you don't cross it out and put nothing. You leave the 1 there because there's no x or other variable. So we ended up with x equals 1. I still have to find the y, but I have some easier equations for that. This time, I'm going to use the second equation to solve for my y. So I'll just rewrite it over here. X plus y equals 4. And then I'm going to take that x equals 1, and I'm going to put it in that equation for x. And you can use this equation, you can use this equation, I don't know if you would really want to, or this one. You should all get the same answer either way. Okay, so 1 is going in for x because we already found x equals 1, and then plus y equals 4. I want to get y completely by itself, so I'm going to have to undo that positive 1. So I'm going to subtract 1 over here and over here. And then 1 minus 1 is 0, so that goes away. I bring down my y, and then 4 minus 1 is 3. So that is the second part of my solution. And then I just need to write it as a single point. So x was 1, y was 3, so in parentheses 1, comma 3. Okay, so last problem. Sorry, I know that I would rather err on the side of giving you like extra examples. That way we cover everything, than try to shorten it and miss out on something or not give you as many examples as you need. So, example 2. Find the solution of the system. 2x plus 3y equals 5, and 14x plus 21y equals 35. Okay, so this is like a good challenging problem. It's not easy. It's not going to be easy. So our goal with substitution is to get a equation that gets to a point where one variable is isolated. So let's say like I want to isolate x. That means I would have to end up dividing the entire equation by 2, which you can't divide 3 by 2, and you can't divide by 5 by 2 either, so that would be tricky. And then same thing here, like if I wanted to isolate the y, I would have to divide everything by 3, which I can't, and the same trend goes for the second equation. So I would say this is like the most challenging problem that you'll see for this type of solving method. So just bear with me. So what I'm going to do is I'm just going to go for it. I'm going to take the first equation and let's say try to solve it for x. So I'll rewrite it over here. So 2x plus 3y equals 5. And then if I want to solve for x, I got to get x by itself. So same like solving steps as if you were solving like a regular two-step equation apply, where we have to use inverse operations. I want to undo addition or subtraction first, so I want to get rid of this plus 3y. So in order to do that, I'm going to subtract 3y from both sides. So I'll bring down my 2x, and then 3y minus 3y is 0, so that goes away, which is what we're trying to do. And then equals 5 minus 3y. Still trying to get x by itself. So there's 2 ways that you can write this next part. I will show you the way that I don't want you to do it first, and then I'll erase it and show you how I do it. So don't immediately like write, just wait till you see like kind of the final result. So we have to divide by 2 because this is like 2 being multiplied by x. So I'll divide by 2 right here. So one way is to divide every single term by 2, which, you know, those are kind of some ugly numbers. I can't divide them evenly, so I don't really want to do that. What I'm going to do is I'm going to write it as a whole, like right side of the equation, divided by 2. And I'm just going to leave it like that for now. And we'll see why in a little bit. So 2 divided by 2 goes away, so I'm just left with x. And then this whole thing, I'm just going to leave it in that structure. So 5 minus 3y equals 2. Okay, so now I have x isolated. So if I am saying, you know, this whole thing is equal to x, I can take that whole thing and put it into the second equation where x is. So this whole thing right here is going to get swapped out for that, or that x is going to get swapped out for that whole thing. So the second equation is going to be like my shell, my base. So it'll be 14. And then instead of times x, it's going to be times this. So big parentheses, 5 minus 3y over 2. And then the rest of the equation stays the same. So plus 21y equals 35. Okay, so now we have an equation, albeit a complicated one, that only has one variable. So now we're able to solve it. We just have to figure out a way to simplify first. So this goes back to like the cross-canceling thing that you can do with fractions. So if you want, you can think of this as like 14 over 1. You don't have to, but like just to kind of recognize this as a fraction times a fraction right here. So I can cross-cancel. So the 14 and the 2, they have a common factor. I can divide them both by 2. And so the 2 would become a 1, and the 14 would become a 7. So now I only have 1's left in the denominator. So that means I don't need to write the fraction anymore. If there's only 1's left in the denominator, I can just write the numerator, 7 times 5 minus 3y. So 7, parentheses, 5 minus 3y, and no more like big ugly fraction. And then I bring down the 2y equals 35. And now I want to go through like the previous steps I did on like the last few problems. So I want to get rid of these parentheses. So in order to do that, I need to distribute the 7. So 7 times 5 is 35. And then 7 times negative 3y, negative 21y. And then I would bring down the plus 2y equals 35. I want to check for like terms on like each side of the equal sign. So I have like terms right here that I can go ahead and combine. Oh, I dropped a 1 at some point. Ooh, I'm so sorry. Okay, you're probably looking at me like, or looking at the video like I was crazy. This was a 21y, and for some reason when I brought it down here, I changed it to a 2y. So I'm gonna just put a 1 right there. I'm gonna erase the whole thing. This is a 21y, and then that means this should have been a 21y also. Sorry, I dropped the 1. So 21y right there. Okay, so now we check for like terms. So right here, I have negative 21y plus 21y. So if I have two numbers that are the same number and but different signs, when I add them together, I get 0. So negative 21y plus 21y together is just 0. So I can even just cross them off. And then I bring down my 35, bring down my equal sign, bring down my other 35. So my variables are gone again, but this time I have something that actually is true. So if it actually is true, that means that it's infinitely many solutions. So when we were graphing, infinitely many solutions was the one where like the two lines ended up overlapping each other, and every point on the line was a solution. So this is infinitely many solutions, and you get that when you're solving the system and the variables disappear, you'll end up getting like two numbers that are equal to each other. Oops, I guess I should put solutions. Ah, no, sorry. Infinitely many solutions. Okay. Okay, so that is it. I just want to compare back to the other like kind of weird answer that was like number 2 up at the very top. So up here, this was when we ended up with no solution, and then down here we had infinitely many solutions. I just want you to recognize that no solution was because the two numbers did not equal each other. Infinitely many solutions was because the numbers did equal each other.